Welcome to the webinar, The Next Era of Chemicals Innovation. My name is Kristen Marshall, Associate Research Director here at Lux, and I will be moderating today's session. Presenting today is my colleague, Yuansheng Yu, Senior Director here at Lux Research. Throughout the webinar, you can type any questions you have in the questions box on your screen. Time permitting, we will answer all the questions we can. If your question does not get answered, please do not hesitate to email it to questions@luxresearchinc.com and we will respond. If at any point you experience technical difficulties, such as a frozen screen, simply refresh your browser and check that your internet connection is strong. Now, let's jump into the presentation.
Thank you, Kristen, for the kind introduction. Welcome, everyone. Thank you all for joining us today as we take a look at the state of innovation in the chemicals industry. Not just the big picture, but direct insights from innovation leaders from the world's largest chemical companies. Let's just address the first thing and get it out of the way. The chemicals industry is currently going through a down cycle. After 11% revenue drop in 2023, things are stagnant in 2024. Add on ongoing geopolitical tensions, regulatory uncertainties. These are all factors paralyzing innovation decisions and eroding confidence in the industry. Then you have weakened demand and global overcapacity that's truly reshaping value chain dynamics that have stood for decades. But none of this is new. The chemical industry has gone through this before, numerous times. From the 1970s oil crisis that sent energy and feedstock costs skyrocketing, sounds familiar to today, to the 2008 global financial crisis that impacted everyone, not just the chemicals industry, to where we are today, where we have kind of a little bit of everything. Of course, organizational restructuring, operational streamlining, and cost-saving initiatives every time was the natural reflex, often with R&D and innovation feeling the cutback first. These headlines here on the screen, they aren't from this year. They're from over a decade ago, but look very similar to the headlines we see today about what's happening to make sure that the next quarter is slightly better than the one before. A quote stood out after the Lux team attended CIEX this year in the US. Tracy Purdom, the editor-in-chief of Chemical Processing magazine, wrote, "The chemicals industry didn't build itself on quarterly thinking. It was built on patient capital and long-term R&D investments." Now, I couldn't agree with her more about how important this long-term R&D kind of horizon thinking has been critical to the chemicals industry success. But at the same time, we won't stand here and say that the CEOs of the world's largest chemical companies have an easy job. They don't. They must make tough decisions, appealing to numerous stakeholders with competing priorities. So that's not what we're saying here. What we're saying is that, to the tune of Tracy Purdom's quote, the chemicals industry has really shifted its focus to the near term, next quarter results, as any good business should do, of course. But in the process, it's lost a lot of bit of its perseverance and commitment and edge that when it comes to innovation that it's historically had. Because ultimately, innovation is the most reliable driver for long-term resilience. Innovation builds resilience for companies going into these down cycles, and the innovation actually accelerates recovery coming out. So today we want to shed light into where innovation direction is going in the chemical industry, and for those companies that have the perseverance to keep pushing it forward. In today's webinar, we'll cover 3 items. First, how have innovation priorities shifted in the last 12 months? As you may recall, Lux introduced a new set of innovation priorities for the chemicals industry a year ago, and today we'll see how that focus has changed. Second, many of the technologies are reaching technical maturity, but still lack of commercial traction. How does Lux assess these technologies holistically, and what key questions are innovation leaders looking to answer beyond just the technology itself? And lastly, what methodologies, frameworks, or approaches should innovation leaders like yourself in the chemicals industry use and adapt to drive successful innovation right now and going forward? So just to refresh, last year, Lux unveiled its Lux priorities for chemicals innovation leaders. It was a pivotal moment for us at Lux to really reimagine the offering and pinpoint the high impact innovation and R&D priorities for the industry. Looking back, one of the most important elements of our client priorities is taking an outside-in, customer-centric approach to ensure we are grounded in comprehensive data, real industry shifts, and of course, aligned to the actual strategic needs of today's chemical innovation leaders. First, the data. We looked at the same 80 chemical companies as last year, analyzed their new annual reports. We combined that with nearly 6,500 questions and over 1,800 innovation initiatives shared with Lux in the past 12 months. Now, this was aggregated, anonymized, but this is insight you don't get from headlines. It's what innovation leaders are actually doing and prioritizing behind the scenes. Second, we applied advanced NLP to uncover recurring themes, patterns, and areas of focus, specifically in the context of technology, innovation, and R&D, giving us deep data-driven understanding of what the industry is paying attention to and quantifying the shifts across the priorities. So, of course, we compared the results to the 2024 results. We also engaged nearly 40 innovation leaders to validate, interpret, and stress test the themes and technologies uncovered. And using this combined approach, we confirmed the continued relevance of the 5 prime priorities and a refined set of technologies important for the next era of chemicals innovation. What really stood out was obviously the shift in the last year. In 2024, it was the year of decarbonization. The percentage you see is the number of companies that had innovation-driven initiatives in each of these client priorities. It was clear that 2024, that decarbonization and defossilization were the top 2 drivers behind any R&D activity. But looking at 2025, there's a clear indication in the shifting of innovation priorities. Notably, the decreases in defossilization and decarbonization, which we'll go into details a bit more later in this presentation. But what jumps out the most is, of course, future materials, as core material sciences gains a sharper focus as an innovation driver for the industry. Now we'll dive into each of these individually, but before that, some notable trends across the sub-industries and regions that Lux serves. As you may recall, Lux focuses on basic chemicals, diversified chemicals, and specialty chemicals. And this year's analysis reveals clear shifts in how each of these sub-industries is refining its innovation strategy. For basic chemicals, defossilization of raw materials and decarbonization of operations remain the dominant priorities. These companies continue to direct most of its innovation initiatives towards reducing feedstock exposure and lowering emissions across existing capital-intensive assets, even as overall focus levels dip slightly compared to last year. But future materials is what truly stands out as the one priority that increased across all sub-industries, reflecting that sharpened focus on materials-focused innovation, increasing 13 percentage points and 21 percentage points respectively for diversified chemicals and specialty chemicals. Regionally, we're beginning to see a divergence in strategic priorities, and these differences matter, especially for companies operating across multiple markets. In the US, regulatory uncertainty is effectively freezing innovation in defossilization and decarbonization. From our interviews, companies are largely stagnant, hesitating to make long-term commitments, but also not really dialing back efforts either, where things have remained flat. In contrast, EMEA is continuing to move steadily, reflecting the more stable policy environment, where several of the innovation activities that have happened in years prior are now maturing and moving out of those teams. But APAC stands out the most, dropping 32 percentage points over the year due to a lack of regulatory clarity and maturity than its Western peers, and continuing to play the quote-unquote, what will the West do game. But of course, future materials saw the most consistent global rise, as noted earlier, for the different sub-industries. Every region also increased its emphasis on advanced materials innovation. But APAC stands out, especially Japanese and South Korean companies really looking to reaffirm their leadership position in sort of breakthrough material sciences. This shift signals the potential that the next wave of competitive differentiation in the chemical sector will be increasingly materials driven. Now, as for uncovering new market opportunities, given a lot of the looming uncertainties with regulations, geopolitical tensions, tariffs, Companies in all regions aim to reinforce sort of existing positions within market segments that they already serve, rather than too aggressively pursue new markets. Although APAC highlights a more active pursuit for expanding into these new segments, especially as the regional market evolves. In addition to this top-down analysis, we of course took a bottom-up analysis and uncovered 76 technologies of strategic interest across the industry. Here on this slide, you see the top 14 technologies overall, ranked in order, and the darker the box shows the focus of that technology within that respective sub-industry. So despite market headwinds, future of carbon technologies like advanced plastic recycling, bio-based chemicals, and CO2 utilization continue to be at the top of the list. Even in today's difficult environment, these technologies remain quote-unquote non-negotiable for innovation leaders for reducing feedstock exposure, closing the material loop, and of course, transforming carbon from a liability into a resource. In basic chemicals, you also see sort of process innovation focus through other high priority technologies like advanced membranes, low carbon heat, and point source carbon capture. What does stand out most is sort of the rising wave of material science innovation. Novel and advanced materials are claiming an increasing prominent share of the top technologies. For example, advanced coatings and advanced composites round out the top 5. And as momentum continues to accelerate, Lux is actually expanding its coverage to include 2D materials, photonic materials, porous framework materials, novel electronic materials, as well as structural performance materials. Several of them you see on this list here to complement its continued coverage of things like thermal management materials and of course materials informatics. And all of these future platform materials, they're really redefining what is possible in terms of performance and functionality to really overcome some of the materials limitations that we see today. Now, while technology remains core to innovation success requires more than just the technology. Over the past 12 months, this latter question, what else is needed for innovation to be successful, has become increasingly prevalent in Lux's conversations with innovation leaders. The reason behind this is because technology alone ignores the complexity of an entire organization's ecosystem. So Lux unveiled its 5 factors of innovation success earlier this year, where it breaks down this complexity into 5 factors. You have product, right? This is the innovation must be a well-defined offering with clear use cases and customers in mind. You have technology readiness. It's what most of the focus is on when talking about innovation. But then you have market organization, which is of course the supporting ecosystem that must exist, including supply chains, logistics, complementary infrastructure, as well as regulations. Then you have market readiness. There must be actual eager adopters and buyers. Even technically sound innovations won't move without market demand. And lastly, you have production. This is about having the right suppliers, engineers, and of course, manufacturing facilities available and aligned in order to scale. But it's not only about the maturation of each of these 5 factors, but it's also the convergence of them all at once that will drive success, especially in a first-of-a-kind investment, many of which is the case for the technologies we showed on the previous slide. And of course, the success of that first-of-a-kind investment is key, as any future investments that truly scales an innovation into the mainstream will be dependent on it. So in the following section, we're going to dive into each of the client priorities. Of course, as always, we'll outline why it's critical, how should the industry act on them, and we'll also take a look at some quote-unquote innovation in action, highlighting sort of innovation progress despite the market challenges. But more importantly, we wanted to take a look at these 5 innovation factors, and we actually will pull from the 6,500 innovation questions that I mentioned earlier to distill down the types of questions innovation leaders like yourself are looking to answer across each of these 5 factors to highlight not only the technologies fundamental to each priority, but how innovation teams are tackling and approaching them. So first, we have defossilization of raw materials. While Defossilization pathways have progressed much more slowly than hoped, with several high-profile setbacks over the past year. Innovation interest remains strong. Shifting global dynamics are exposing new pressure points within traditional fossil-based raw material supply chains, and these forces highlight why supplementing conventional value chains with more resilient carbon sources remains a strategic necessity. Of course, this requires balancing what can truly be deployed now and what will be required in terms of development for the long term. The reality is clear, though. A full-scale transition remains unrealistic. So instead, it's about leveraging alternative carbon sources as one of the levers for more localized and resilient supply chains that can complement rather than replace incumbent materials. Now, for the innovation into action, we found one notable development. And trust me, this year, going through preparation for this webinar, it was actually quite challenging to find something from the last 12 months that wasn't bad news in the industry, but we were able to find a couple. And for this one, it's Haldor Topsoe announcing that it would supply a 55 megawatt solid oxide electrolyzer system for Forestal's e-methanol project in Spain. So this not only marks the first one of its kind to attempt SOEC at such a large scale, but it also shows the establishment of a local methanol source within Spain. And why is that important? Because if we look across the 5 innovation factors of success, there's not only a wide range of technologies for defossilization, like advanced plastic recycling, biomass gasification, CO2 utilization, low carbon methanol, and even bioplastics. There are very different challenges that innovation teams are looking to address. Building on the innovation exaction from the previous slide, the innovation factor I want to highlight here is market readiness, the second one on the right. Specifically, which customer segments show credible near-term demand for low-carbon methanol. So again, the technology to produce low-carbon methanol is technically ready, and as you saw from the innovation example, there's market organization already happening in terms of electrolyzer suppliers, CO2 capture providers, the catalytic conversion technology provider. But downstream market readiness, what customer segments will actually buy this? And the answer to that is really going to be the marine and aviation sectors as shipping and jet fuel, respectively. Methanol is increasingly being recognized as a viable alternative fuel in the shipping sector, although, of course, the one-year delay of the IMO agreement just a few months ago has caused a ripple effect and several delays. More midterm, in the aviation sector, is the use of methanol as the input material for alcohol to jet fuel as well. Now shifting to decarbonization of operations. So, of course, as decarbonization headlines have really softened over the past year, chemical companies continue to anchor their strategies around net zero and carbon neutral commitments. Many near-term levers, including energy efficiency, fuel switching, and partial electrification, are already being deployed, and responsibility is actually shifting from innovation teams to operational units. But ultimately, decarbonization is essential for future-proofing operations. Of course, there are several reports of underutilized plants and plant shutdowns, especially in Europe, which really underscores a lot of the mounting pressures from lower cost competitors. But the reality is that wholesale divestment is neither practical or desirable, reinforcing the need to build a comprehensive decarbonization roadmap, accounting for the long-term resilience and operation of these assets. As for innovation in action, the recent FID from Air Liquide to build a 200 megawatt electrolyzer at the Port of Rotterdam to supply green hydrogen to refineries in Belgium and Netherlands highlights how alignment of public-private sectors, especially government subsidies, as well as alignment of generation, transport, and end use is possible. And again, we see a wide range of technologies of interest for decarbonization, from end-to-pipe solutions such as carbon capture, and a growing interest in things like low-carbon heat. But for the innovation factor production, Air Liquide's FID in the Port of Rotterdam is the perfect example of a signal of the right suppliers, facilities, and end users aligning to scale. Now, moving ahead to future materials, the driving theme behind innovation in the chemicals industry and the driving theme behind our next era of chemicals innovation 2025 update. Um, it's not just about the material itself, right? It's about pushing the boundaries of discovery and design alongside it. It's about building a strong portfolio of future platform materials that will position companies to capture opportunities when incumbent materials are reaching their materials limit. However, as we've learned in the past, many transformative advances in material science have struggled to achieve commercial impact due to lack of market readiness, and where overly high promises have led to more disappointment than disruption. Accelerating materials discovery, design, and development will also enable chemical companies to potentially do more with less and remain agile as new market opportunities emerge. A great innovation in action for accelerating materials discovery and design is the implementation of generative AI, which has led to substantial funding rounds, such as the one you see here from Periodic Labs, raising 300 million USD, which makes it one of the largest in the space ever. But while market readiness is key for future materials, such as identifying the market segments showing the strongest demand for novel thermal management materials, which is data centers, of course, the technology readiness is also important, especially for the integration of AI and materials informatics. Yes, while we are seeing record-breaking funding rounds, the capabilities remain vastly overstated for Gen AI-enabled materials discovery. They really should just be viewed as tools for accelerating, not disrupting, materials discovery by narrowing search spaces and, of course, speeding up early-stage R&D, which is, of course, extremely beneficial in a time of limited resources. However, they are not a shortcut to commercialization. Now, uncovering new market opportunities as we kind of sort of shift and transition from process innovation to core material science to more product innovation. The markets that's served by the chemical industry are rapidly evolving. I think this has been the story for much of history. New technologies emerge, new performance expectations rise, and in order to stay ahead, the ability to anticipate and respond to these shifts is going to become a defining competitive differentiator, especially if you're moving into adjacent or entirely new market spaces. Forward-looking companies are looking to exploit these faster than GDP opportunities, either through existing materials or the creation of entirely new ones. However, many of these new market opportunities aren't fully tangible, right? Companies must distinguish between real growth opportunities and just speculative trends. So not every opportunity will mature, and product strategy roadmaps must be grounded in clear signals from technological advances, customer needs, and market momentum. And one signal would be something like Scion Power's 75 megawatt hour pilot line for its lithium metal cells, which is a signal of an emerging opportunity gaining traction. Lux views this as actually a tipping point where lithium metal could reshape EV battery pack design by reducing weight and cost, developing into a real growth opportunity to pursue in materials and, of course, equipment aligned with lithium metal's path to scaled manufacturing. And this development is the exact type of signal innovation leaders are looking to identify for the production innovation factor. While there are obviously new opportunities in products like advanced sensors or looking at how market organization is shaping up for something very early stage like quantum technologies, this production innovation factor about which manufacturers for novel battery chemistries are expanding nameplate capacity or opening new product lines is the signal that innovation leaders are looking for before pursuing a new market opportunity. Now, the last but not least priority is, of course, harmless chemicals. Just like last year, we do want to clarify, when we say harmless chemicals, we do mean less harmful chemicals. And ultimately, these are any product or chemicals that helps minimize health and environmental impacts at the end of the day. And the trends remain the same. There is rising public awareness of health and environmental risks, combined with increasing regulatory scrutiny, and it's placing mounting pressure on the chemicals industry. Over the past several decades, numerous widely used chemicals have been banned or tightly restricted, But today, these risks are further amplified by, of course, the consumers who are more informed or maybe misinformed about chemical exposure and their health risks. So these less harmful chemicals that are needed, they're needed for both a compliance imperative, but also a requirement for maintaining a social license to operate. Within your organization's regulatory affairs functions already deeply engaged in portfolio and product management, but innovation leaders also have a role to play where chemicals are voluntarily phased out due to consumer concerns to mitigate risks against reputational damage. But not all harmful chemicals need to be replaced, and not all regulations will come with urgency. The U.S. announced, specifically the Pentagon announced delays to remediation efforts at various Department of Defense sites. And this actually will push back projects by over a decade, and it shows how sort of volatile and uncertain the market conditions are for something like this. However, it still leaves innovation opportunities for innovations in detection, treatment, and destruction before these pollutants even permeate into the ground and surface water sources. So a broad portfolio of technologies are relevant to harmless chemicals, from alternative inputs for agriculture to green chemistry platforms like synthetic biology, and of course, end-of-pipe solutions like advanced membranes and industrial wastewater management. But a key innovation factor here is, of course, market organization, especially for industrial wastewater management. Market organization remains key as there really lacks a one-size-fits-all solution. So we are seeing a lot of incumbent players partner and even acquire differentiated offerings, both up and down the value chain, to one, maintain a very broad solution portfolio, and two, be able to offer vertically integrated solutions. This is kind of what we're seeing in terms of trends of what's to come. So we've gone through the core of the chemical industry's innovation priorities, how they have shifted over the last year, and also taken a holistic view of some of the most relevant technologies as well as questions that are driving innovation success. But now it's time to act. As again, innovation is the most reliable driver for long-term resilience. So how do you build innovation for resilience going into these down cycles? And how do you build these innovations so you can accelerate when recovery occurs? The first one is the industry can't stop discovering and dabbling, discovering new scientific breakthroughs, and dabbling by tinkering, testing, and thinking about the potential applications it can serve. Now, the LuxTech signal provides an integrated signal of science, investment, and commercialization. So it makes it uniquely suitable for tracking early scientific efforts and the moment when they get picked up by inventors and investors. So discover, analyze all the breakthroughs you hear about. Track these developments to determine if it's truly something you would label a breakthrough, not a breakthrough because someone else says so. And then, of course, dabble, because you can't expect to predict the impact of a scientific breakthrough. Some are predictable, but others really only emerge in the dabbling phase. So use this chance to pick your winners, not before that. And aside from the key questions answered, what other purpose does the 5 factors of innovation success serve? They are actually the weak signals that you should be listening for. The weak signals methodology follows 3 steps. First, you imagine, where you envision a possible future. Then you listen by identifying early signals that this vision is materializing. And then you amplify. You explore the full consequences if the signal becomes mainstream. So by systematically listening for weak signals across product, technology readiness, market organization, market readiness, and production, these early, often overlooked events can potentially foreshadow larger changes that can really guide and drive some of your innovation efforts. And lastly, leverage your innovation roadmap as a communication platform across the organization. Make sure you involve all stakeholders when developing the roadmap by posing the right questions downwards so that you're able to get the most relevant answers upwards. More importantly, the collaborative approach creates an alignment across various levels and functions, leading to greater involvement and, more important, accountability, so that um, changes in the perception of innovation and the bridges in the communication breakdown that currently limits innovation can be fixed. Now, for all three of these things I highlighted, I would love to point you to some of the webinars that my colleagues have put out about innovation road mapping, about the weak signals methodology, as well as the discover dabble approach in terms of scientific breakthroughs. But with that, I do want to thank you all for, and then the key takeaways at the end of the day here are, number one, fill out the front end of your innovation funnel. Do not lose sight of the technological developments that are gaining momentum, and proactively fill your front end of the innovation funnel with noteworthy breakthroughs. One of the biggest concerns that chief innovation officers and chief technology officers have shared with us over the last 12 months is that a lot of the KPIs driven by near-term objectives has raised fears of emptying out the innovation funnel. So when this period passes, there's not much to lean back on going forward. Number two, which was the theme of all of today's presentation, assess innovations beyond technological momentum. Think about all the developments across those 5 factors of innovation success, and use those in order to work on your timing, the size of your innovation bets, as well as the strategic actions that may be needed for you to influence or change how one of those factors are behaving. And lastly, looking back to the innovation roadmap, you need to create organizational alignment for your innovation initiatives. Use those roadmaps as a platform for communication and dialogue for all stakeholders across the organization. And 2, use that innovation roadmap to speak the same language and tell the story of why some of these innovations are critical for your organization's success, not only in the near term, but in the long term. Now, with that, we thank you for your time and joining today's webinar, and we'll now take a few questions from the audience.
Great, excellent. So we will now be taking questions. Please type your questions into the questions box on your screen. If we do not get to your question during the webinar, someone from Lux will be in touch. Awesome, okay. So the first question here, so Lux has identified future materials as having greater importance as an innovation priority. How does Lux determine if a future material is technically transformative or has actual commercial impact?
Yeah, absolutely. And I think that's the holy grail question, right? We've covered materials, advanced materials in the past at Lux that just lacked any commercial traction. I think the key here is really 3 factors. Number 1 is the performance of that material. Does it truly offer leapfrog potential or a stepwise change in performance compared to the incumbent? 2, of course, is system readiness in terms of manufacturability, scale up in production as well. And the third one is some market trigger and some market pull. I think carbon fiber is the perfect example. Carbon fiber was around for several decades before it sort of moved into mainstream, specifically starting with the aviation sector. But carbon fiber was able to break in due to its 3 times specific strength compared to aluminum. It was ready to be manufactured in terms of composite fabrication. And the aviation sector had many market triggers, such as high fuel prices, emission mandates, and kind of a desire for better fuel efficiency. It was sort of the convergence of all these that really led to its success. So when Lux looks at these future materials that we highlighted, such as novel electronic materials, 2D materials, porous framework materials, the technical element is important, but really it's then we'll be looking at these 3 factors as well from the market side to see if they really have a commercial impact.
Great. Okay, next question. So for the 5 factors of innovation success that you highlighted, can you further describe how they can be operationalized by innovation teams?
Yeah, absolutely. So I kind of touched on it at the very end there, but it's really about weak signal monitoring. Um, of course, any noise can be a weak signal, but these 5 factors allow you to systematically and categorize the types of weak signals you're listening for. Many of the innovation in action examples provided during the presentations are sort of the weak signals that we would kind of capture at Lux related to each of these 5 innovation factors. And it really helps you start to track and monitor whether or not a tipping point was reached where it could shift in favor or against a technology success. So that would be part of a kind of ongoing monitoring that innovation teams should be doing.
Okay. The next one is good. So in Lux's opinion, are harmless chemicals going to be the next sustainability when it comes to a major trend that doesn't lead to real business opportunities?
Ooh, I don't believe so. I think harmless chemicals will lead to real business opportunities and sort of real tangible growth opportunities. My main reason and kind of reasoning behind that was it's directly affecting the consumer. Sustainability was about the world and the globe and the environment. But when you talk about harmless chemicals, it's about you yourself and what you're ingesting, what you're exposed to. And I think due to the normal human nature of kind of wanting to protect yourself, any momentum around harmless chemicals should likely lead to real tangible opportunities, not just a trend that sort of fades out. I think I always like to use BPA as an example. Sort of that was a thing during my childhood growing up. There was this big push against BPA-free plastic water bottles, containers, etc. And you can see how that really led to a real business opportunity for materials developers.
Yep, absolutely. Even things that don't contain or would never contain BPA have that label on it.
Of course, because it's BPA free still.
Yeah. And then I think we have room for one more question. So can you elaborate further on why decarbonization and defossilization technologies like CO2 utilization are so high on your list?
Yeah, that's a good one, and it's one we get very frequently, especially if you look at the Lux Innovation Radar. Several of those technologies are in the top 10. Ultimately, there's 2 ways to look at these technologies, right? CO2 utilization, bio-based chemicals, advanced plastic recycling, etc. There's the large CapEx projects that need to be developed to scale these technologies, and then there's the innovation momentum and innovation activity within these technologies. Obviously, the headlines for the large CapEx projects have not been good over the last past year, right? Delays, cancellations, postponements, etc. And that makes sense given the current market environment, current regulatory environment, and the amount of uncertainty right now macroeconomically. However, in the background, innovation hasn't slowed down. So, for example, many of these technologies have seen 100% plus year-over-year increase in VC funding, patent activity, academic publications, etc. So while they haven't moved into sort of the business operation portion of the industry, they are still very integral to the innovation teams and functions.
Yep, absolutely, and key for that long-term, success of companies that you mentioned at the beginning. All right. Well, thank you so much, Yuancheng, for your time and a wonderful presentation. So that concludes our webinar for today. The slide presentation and recording will be sent to all attendees via email. After leaving the webinar, you will be prompted to complete a survey on the presentation. We really would appreciate any feedback that you have that will inform and improve on future webinars. And take a moment and check out our upcoming webinars on our website. Thank you so much for your time and have a great day.